Up on the screen, we got special right triangles. There are two special right triangles, a 45-degree, 45-degree, 90-degree triangle, and a 30-degree, 60-degree, 90-degree triangle. Two special triangles. Now, here's the theorem. If you have, well, we know a 45, 90-degree triangle is an isosceles triangle. So therefore, if this bottom is x, then this one should be x because the isosceles triangle has two legs that are equal or congruent. And now, what about this one? Well, for all of these, you can use Pythagorean theorem to solve this out. A squared plus b squared equals, let's just say that this is the c. What is 1x squared plus 1x squared? That would be 2x squared. That's equal to c squared. How do you get rid of squaring both sides? You're trying to get c by itself, so you take the square root of both sides. And so if we look here, we're going to have the square root of 2 and the square root of x squared. Well, what is the square root of x squared? X, and the square root of 2 is this. And so this is where it's coming from. You can use Pythagorean theorem for all of them. But if you can remember these special right triangle theorems, it saves you so much time on problems that involve these special right triangles. Let's look at a couple examples. Find the length of the legs of the triangle. Last slide I told you use Pythagorean theorem. I was just kidding. On every problem you can't use Pythagorean theorem. But since this is 45 degrees, you can use sine, cosine, and tangent, right triangle trigonometry here to solve this out. But it's going to be quicker if you memorize the theorem, right? If this is x, that's also x. Because this is 45, and this is also 45. And then what is this one right here? Well, this is x times the square root of 2. Really? So now how do we solve this out? Well, how do you get x by itself? You divide by the square root of 2. You divide by the square root of 2. Cancels. So now x is equal to the square root of 50 divided by the square root of 2. But remember, can we do some simplifying here? The square root of 50 breaks down into 25 and 2. The square root of 25 times the square root of 2. And the square root of 2 is on bottom. And so from here, cancel those out, leaving us with the square root of 25. But what is that? That is 5. So therefore, x equals 5 for both of them. I'd like you to try this one on your own. Pause the video, hit play when you're finished, and check your solution with mine. Oh, I know those are congruent, so this is x, this is x, this is x square root of 2. Divide by the square root of 2, divide by the square root of 2, cancels. So x is equal to 18 over the square root of 2. But you cannot have a square root on the bottom, so we have to rationalize the denominator and multiply it by 1. But 1 is going to be in the form of square root of 2 divided by the square root of 2. So 18 times the square root of 2. And on bottom, the square root of 2 times the square root of 2 should give us 2. 18 over 2 will reduce to 9. X equals 9 square root of 2. And that is for both of them, since it is an isosceles triangle. All right, if you're given the legs, well, you know this is 10 and this is 10, so it must be an isosceles triangle. If this is 90, these two angles must be congruent, and if they're congruent, they have to add up. Since this one is 90 down here, they have to add up to equal 90, therefore there, 45. So it's a 45, 45, 90-degree triangle with the legs equaling x, and this equals x times the square root of 2. So we just substitute in x times the square root of 2. You plug a 10 in there. You can't really simplify anything, so the hypotenuse is 10 times the square root of 2. Sort of as plugging it into the Pythagorean theorem. You go ahead and try to figure this one out on your own. Pause the video, hit play when you're finished, and match it up with my solution. Find the length of the hypotenuse of the triangle. So we know this is equal to x. So we're going to say the hypotenuse is equal to x times the square root of 2. Couple different things. You could go square root of 10 times the square root of 2. But I know I'm going to have to simplify that. And I'm going to break up 10 into the square root of 5 times the square root of 2. And then I'm dropping down that square root of 2 there. And why did I do that? Because square root of 2 times the square root of 2 is just 2. I have the square root of 5, and I'm going to have 6. Go ahead and multiply 6 times 2 to get 12. 12 square root of 5. You could have multiplied square root of 10 times square root of 2 and got the square root of 20. 6 square root of 20, and then 6 square root of 4 times the square root of 5. 20 breaks down into that. Well, this is just 2. 2 times 6. Either one of those will work. Alrighty, the next special right triangle. And these triangles, they sure are special. Here's the theorem. Hypotenuse is twice as long as the small leg, and to get the longer leg, it's just the small leg times the square root of 3. So, identify things. This is the hypotenuse, this is the long leg, and this is the short leg. Well, the short leg is always x, the hypotenuse is 2 times x, and the long leg is x times the square root of 3. Well, since x equals 10, 2 times 10 is 20. Hypotenuse is 20. Also, since x is 10, you plug it in for x. The longer leg is 10 square root of 3. It's a lot quicker than using your right triangle trigonometry skills. If you have that theorem memorized, it saves you some much needed time. Yeah. All right, let's try this one on your own. You try this one. This one here is the hypotenuse. It's important to notice that this is 60, and so that one must be 30, because they must be add up to 90, since that one is 90. So go ahead and work it out on your own, see what you can come up with, and then check your solution with mine. I know this is the short leg. The short leg is across from the smallest angle, so this is the longer leg. Short leg is equal to x, longer leg is equal to x times the square root of 3, and this is the hypotenuse across from the right angle, which is equal to 2x. So let's solve for x. X equals 21. So short leg is 21. Longer leg must be 21 times the square root of 3. There you go. Okay, and this one here, we're going to solve it the same way. Since we have a 60 down here, This is 90. This one must be 30, so therefore we can use our special right triangle. Across from the 30 is the short leg, which is x. Across from, let's say, across from the right angle, this is the hypotenuse, which is equal to 2x. And across from the 60 is the longer leg, which is equal to x times the square root of 3. Okay. Well, how do we get this? Look at the hypotenuse, divide by 2, leaves us with x is equal to the square root of 75 divided by 2. But you know what? I'm not a big fan of the square root of 75. Because the square root of 75 is the square root of 25 times the square root of 3, and the square root of 25 is 5. Square root of 3. That's what I would much rather see this as. 5 square root of 3. And this, I would like to see it as 5 times the square root of 3 divided by 2. Alright, now this one over here, the longer leg, we're going to have to do some work. So let me clear off some room. So we say the longer leg is equal to 5 times the square root of 3 over top of 2. That is x. Okay, we got that from the short leg. So we got that from the short leg. That's x. And then we multiply it by the square root of 3. That's just the 30, 60, 90 theorem tells you to multiply x times the square root of 3 to get the longer leg. Now, how do we do this? Well, it's a fraction, right? Put that over 1. Multiply the top numbers. 5 does not have any other numbers to multiply by. And then you multiply the radicals. The square root of 3 times the square root of 3, well, that's the square root of 9, which is, you didn't even have to go to the square root of 9. And then on bottom, 2 times 1 is 2. So 5 times 3 is 15 over 2. So the longer leg is 15 over 2. Or 7.5 if you need to change it to a mixed number. Key here was making sure that you simplified the radical. Make things a lot easier for us. Okay, you try this one on your own. Hit pause. Try it on your own. Well, we know this is the longer leg. This is the short leg. And this is the hypotenuse. Well, let's find the short leg. The short leg is x. Hypotenuse is 2x. And we know that this is x times the square root of 3. So how do we get x by itself? We divide by the square root of 3. Divide by the square root of 3. So now we have 12 divided by the square root of 3. We cannot have the square root of 3 on the bottom because we have to rationalize the denominator. So we multiply it by 1 in the form of the square root of 3 times the square root of 3. 12 times the square root of 3 is this. And the square on the bottom, square root of 3 times the square root of 3, well, that's just 3. It's part of the reason why we rationalize the denominator, so we get rid of the square root on the bottom. How about 12 and 3? They cancel, right? 3 goes into 3 once, 3 goes into 12 4 times. So therefore, we just calculated x, right? X is equal to 4 times the square root of 3. It's the short leg. The long leg was 12. Now let's find the hypotenuse. The hypotenuse is equal to 2 times x. And in this case, it is 2 times 4 times the square root of 3. 2 times 4 is 8. And then the square root of 3. That's the hypotenuse. Special right triangles. Memorize your theorems, and that'll help you out along the way.